In this video, we're going to take up one more problem on shafts. The problem number 14, it reads as, a solid circular shaft is required to transmit 100 kilowatt at 180 RPM. The permissible shear stress in the shaft is 60 Newton per mm square. Find suitable diameter of the shaft if the angle of twist is not to exceed 1 degree in a length of 3 meters. The value of modulus of rigidity is 0.8 into 10 to the power of 5 Newton per mm square. So first we're going to take up the data, which is capital N will be having 100 kilowatt and small n is 180 RPM. The tau is given to be 60 Newton per mm square. They find the suitable diameter, so D of the shaft, if the angle of twist theta is not to exceed 1 degree, that is 1 degree, which will be equal to 1 into pi by 180 radians in a length of 3 meters. So L will be equal to 3 meters, which is equal to 3 into 10 to the power of 3 mm. And the modulus of rigidity G equals 0.8 into 10 to the power of 5 Newton per mm square. So first we want to find out what is the power transmitted by the shaft, which is capital N will be equal to 2 pi n into T mean divided by 60,000. So substituting the values, you know the capital N is 100. So capital N is 100. You substitute that equals 2 pi into n, which is 180 into T mean divided by 60,000. So on simplification, you will going to get the torque, that is the T mean, will be equal to 5305.165 Newton meter. So torque transmitted by the shaft capital T will be T max will be equal to, so here 5305 into 0.165 into 10 to the power of 3 Newton mm. So maximum torque which is given to be, the maximum torque which is given to be here is T, which is 5305.165 into 10 to the power of 3 Newton mm. Now we will going to find out what is the diameter of the shaft based on the strength. So the diameter of the shaft based on the strength, which is pi T, will be equal to pi d cube by 16 into tau. So you know the torque value, which is 5305.165 into 10 to the power of 3. Substitute that, which will be equal to pi by 16 into d cube into tau is 60. So on cross multiplication and simplification, so the diameter of the shaft D will be equal to 76.65 mm. So diameter of the solid shaft based on strength, which is D, will be equal to 76.65 mm. Now we are going to consider the diameter of the shaft by considering the torsional rigidity or stiffness, which will be from torsional equation G into theta by L will be equal to T by J. So where J is the polar moment of inertia, which will be equal to pi d to the power of 4 by 32 for a solid shaft. So now you substitute the values. Well, here we have torque, which is 5305.165 into 10 to the power of 3 divided by J, that is the polar moment of inertia, which is pi d to the power of 4 by 32, which will be equal to G, which is 0.8 into 10 to the power of 5 into theta, which is 1 degree, which is equal to 1 into pi by 180, which is divided by 3.3 meters, which is 3 into 10 to the power of 3. So on cross multiplication and simplification, the diameter of the solid shaft based on the torsional rigidity is given by the D will be equal to 103.8 mm. So once we found out the diameter of the shaft based on the strength criterion and also on the rigidity criterion, so we will going to adopt by comparing these two. We will say the bigger diameter has the permissible value. So select the bigger diameter as the permissible value. So by considering from the strength criterion and also from the rigidity criterion, the diameter of the solid shaft based on the torsion rigidity have got a higher value. Therefore, it has been considered as the permissible value. Therefore, select bigger diameter as the permissible value. So therefore, the diameter of the solid shaft D will be equal to 103.8 mm. So this is how you will be able to analyze and solve this problem. Thank you.